In this video, we're going to go through 3 different parts of linear functions, so that's a bit of a variety, but it's okay, they all do relate in some way. So we're going to start with defining linear functions, then we're going to move on to finding out if a point is on a line, and then lastly, it's going to be finding the gradient from 2 points on a line. Linear function is just a function that has a graph of a straight line. That means that it will have the equation of y equals mx plus c. That's what we've been working with. If we're able to rearrange an equation to put it in the form of y equals mx plus c, that means that it is a linear function. To see if something is linear or not, we need to look to see if we can put it in the form of y equals mx plus c. So our 2 options that we have are 5 minus x, because that can actually be negative x plus 5, as well as 3x minus 5. We now have y equals x to the power of 3 and y equals 2 over x. Neither of those are going to be linear. This is because you can't write it in the form of y equals mx plus c. With x cubed, you can't get rid of that power of 3. It's going to be there, so we can't change it. And then also with 2 over x, we can't get it out of the denominator. When asked if something is linear or not and you're given the graph, this is actually the simpler version. So you just say if it's a straight line, it's linear. If it's not, then it's not linear. Alrighty, we're done with the first part of the video. We've defined the linear functions. Now we're going to actually determine if points are on a line. To check if a point is on a line, you're just going to simply substitute the x value in from your point and solve for the y value. If you get the same answer as the y value in your point, then that point is on the line. If it's different, it means it's not on the line. In this first example, we're going to check if the point 3, 6 is on the line of y equals 1/2 x. So step 1, substitute in your x value. So instead of x, we're going to have 3, so we have 1/2 times 3. Step 2 is to solve for the y value. So just simplify the right side and we get y equals 1.5. Last step is to check to see if it's the same y value as it was in my point. So I've got 1.5, I need to compare it to 6. As you know, those are not the same. So that means the point 3, 6 is not a point on my line y equals 1/2 x. Here's another example. So we're checking if the point 2, 9 is on the line y equals 2x plus 5. So again, first step, substitute in the x value. So it becomes 2 times 2 plus 5. Next step is to simplify it. We get y equals 9. Now that's the same as our point, so it means this point is on the line. Alright, on to our last part of this video. We're just going to be finding the gradient from 2 points that are on the line. The gradient of a line is just simply the difference of the y coordinates over the difference in the x coordinates. So the formula is m is equal to y2 minus y1 over x2 minus x1. Now this looks a bit confusing, but we're going to go through examples and hopefully it'll make more sense then. We're trying to find the gradient of a line that's joined between the points -3, -2, and 5, 4. Now our first step is just to simply pick which one is point 1 and point 2. It doesn't matter which one we do, so I'm choosing to pick the point 1 to be 5, 4 and point 2 to be -3, -2. Our formula is y2 minus y1 over x2 minus x1. We're going to use our points to substitute those in. So y2, -2, minus y1, so minus 4, over x2, so -3, minus x1, so minus 5. When we simplify the top and bottom, it becomes -6 over -8. Now remember, a negative divided by negative just makes a positive number, so we can look at it as 6 over 8. And then last step is always simplify your fraction, so our gradient is 3 over 4. That's all for this video. If you have any questions or concerns, just post a comment on Show My Homework and I will get back to you as soon as I can. Thanks!